Today I'd like to talk to you about my residential heat pump replacement project and the important part that Ingram's Water and Air has played in this project. My original system was installed in 1994. It was a fairly reliable 5-ton geothermal heat pump. This is the second major repair that I'm facing. Both the first and the second repairs were compressor problems. The ground loop, one of the most expensive parts of the system, works fine, so I decided to reuse it. My first decision was, what basic approach do I want to follow here to install a new system? Or do I want to repair my system? The first option was to repair the system. The second one was to replace my current geothermal unit with a new one. And the third option was to replace my geothermal unit with a conventional system. After weighing the options and the pros and cons, I decided to replace my current geothermal unit with a new one. Having decided to replace the system, my next question was, how do I replace it? Do I use a local company, or do I treat this as a do-it-yourself project? The original installer, as I said, could not replace the unit, and available companies were several miles away, and it was an expensive proposition, nearly equal to the original install cost, including the ground loop field as well as the ductwork for the system. As a do-it-yourself project, it's not exactly a cakewalk either. Although it's not a difficult job, I needed to find a vendor who would work with me, and I also needed someone that would be able to give me some advice during the install and maybe provide some support after the install. Obviously, I decided to do this as a do-it-yourself project. I started by doing a web search. I searched for do-it-yourself geothermal heat pump, and one of the first ads that came up was an Ingram's Water and Air ad. I called Ingram's Water and Air to discuss the project. They were very helpful and answered a lot of questions related not only to the installation, but also the options to reuse parts of my system. They had superior responsiveness to my questions compared to other companies that I contacted from a similar search. My plan to proceed with this do-it-yourself project was to make the purchase, which included a consultation, equipment selection and purchase, and coordinating support. The second step was uninstalling the old equipment. The third was installing the new, and the fourth was commissioning the system. The most important part of the purchase process was the consultation. This is where I discussed with a representative from Ingram Water and Air the size of the unit and talked about the capacity and the physical dimensions of the system. I also talked to him about the thermostat and my desire to maintain an energy efficient system. Another big consideration was, what did I need to do to reuse the ground loop equipment? Because I did have an aging system, but everything looked pretty good. And then they also pointed out that I needed to make sure I had someone available to commission this system. Someone who was just a qualified AC, HVAC person who could deal with the refrigerant and make sure that the coolant levels were correct. After the consultation, I ordered the system. I ordered a 4-ton GeoCool unit, pictured here. Actually, mine was a left-facing system instead of a right-facing system. And I purchased the thermostat, and then I reviewed the purchase with my friend who does the HVAC work. After the purchase, the equipment arrived within 2 weeks. Pictured here is a copy of the specification sheet from the heat pump. As you can see, I purchased a GeoCool CFX048 heat pump. That is a 4-ton heat pump. Included in these specifications are the specifics for how much heat, how much cooling capacity the system has, the physical dimensions of the system, as well as the ground loop rates and what's required from a flow rate. These were very important to whenever I had my consultation with my friend who just looked over things and helped me get the plumbing hooked up right. Uninstalling the old system was a breeze. I disconnected the electric, I disconnected the thermostat, disconnected the ground loop, disconnected the ducting, and pushed the old system aside so I could make room for the new. When I disconnected the electric, I did discard the breaker because I had to replace it with a smaller one. And I discarded the thermostat and making sure that I recycled that because my old thermostat had mercury in it. Disconnecting the ground loop was pretty easy. I just cut some plastic pipe, and I had to discard some plastic piping, but it's not a big deal because I just added some additional piping to replace that. And in disconnecting the ducting, I disconnected the entire intake duct, but the output duct I reused almost the entire thing because I was reusing the strip heat that was already there. Reconnecting the system was not a problem either. The unit was very close to the original size, and as I said, I reused the strip heater, so the entire top part of the duct stayed the same. The input ducting changed pretty dramatically. I installed a new type of filter, and the filter input was a lot different in terms of size and capacity, so I installed a high capacity, high efficiency filter. It was, I think, a little bit better than just a single monthly change filter that was originally provided with the system. The ground loop connection wasn't exactly easy, but it wasn't too difficult either. I had two pumps that were both at a 240 volt level, and I replaced them with a single 110 volt pump. The 110 volt pump was going to be wired into the system with a solenoid, and I'll get to that in a minute. But I also had to install some valves. Now the valves are pretty important here because the valves are needed to regulate to a temperature, and so I had to be able to slow down the flow to achieve a certain temperature difference between the input and the output of the coil. For the electrical connection, a 60 amp breaker was replaced with a 40 amp breaker, and a relay was installed to turn on the pump when the fan kicked on. Also, a thermostat was wired according to the instructions that were provided in the box. After the electrical was ready to hook up, we commissioned the system. I first started the ground loop power. I directly connected the power to a 110 circuit for a few days to remove any kind of error, and then I connected that power to a relay that we had added to the system. After that, we connected the system power. My friend, who was the HVAC person, verified the superheat, verified the thermostat operation, and adjusted the ground loop flow, so that it was working at a 10-degree differential, which was what was recommended by Ingram Water and Air. You can see the system was a dual air. You can see the model and the commissioning date. The final steps of the installation, definitely not things to forget, included the installation of a condensation trap, which was required for proper drainage. If it's not installed, there can be some pullback of some water that might accumulate in the system. Also, the disposal of the old unit. In disposing of it, the first thing was to reclaim the refrigerant. Then we dismantled the whole system for recycling. The easy things to recycle included the sheet metal, the copper, and the brass. Some other things are a little bit more difficult to recycle, but we had no problem doing it. It was the condenser, the compressor, the exchange core, and then the thermostat. My main thing here was to minimize the waste. And last, but definitely not least, I need to send a few thank yous out first to Ingram's Water and Air Equipment for the help that they've provided, and for them to provide this option of a do-it-yourself type project for something that could have been very expensive. And I also need to reach out to my friend Dan at Hoover Heating and Air Conditioning. They sell and service most conventional HVAC systems for residential and business customers. Anyone in the Evansburg, Johnstown, Altoona area, please look up Dan, and he's a great guy to work with.